Hey there, ladies and gentlemen, it's Mr. Gordon here. Today, we're going to go ahead and finish up our notes on algebraic proofs. Basically, how this is going to work is I will pause for about 45 seconds or so for each new slide and give you a chance to write down the information. And then we will slowly but surely go through each proof. Okay. Um, for solving proofs, remember, we had the 4 steps that we used yesterday, and they're to the right of the board there. Number one, we start with the givens. We always start with the givens. So in this problem, which you should have written down at the end of class yesterday, our givens are that B is the midpoint of AC, C is the midpoint of DE, and we know that AB equals CE. So my first statement is that B is the midpoint of AC, C is the midpoint of DE, and that AB equals CE. So I start with my givens. Step 2 is to do this kind of step by step. And 3 is to give a reason. So, ladies and gentlemen, what was the reason that I can say B is the midpoint of AC, C is the midpoint of DE, and AB equals CE? It is our given. It's our given information. And then remember, step 4 is just saying, hey, whenever you get to the part that you're trying to prove, which in this problem is right here, BC equals DC, you know you're done. So let's go ahead and look at what would statement number 2 be. Well, first thing I want you to notice before we even get to statement number 2 is that in my givens, I wrote all the given information as my first statement. Okay, I did not need to write 3 different statements and 3 different givens. I could just write all of them at once and write one reason because they all had the same reason and they're happening at the same time. So statement number 2 here is that AB equals BC. So this length right here is the same as this length right here. And I also know that DC, which is this length here, is the same as CE. So I know those things are true. Why? How do I know those things are true? Well, that is the definition of midpoint. The definition of midpoint in your packet says that midpoint splits a segment into 2 equal lengths, and that's exactly what that's doing. So next, I know I'm trying to prove that BC is the same length as DC. Well, I don't have anything to compare with those right now, but I do have another piece of given information I haven't used yet, and that's that AB is the same as CE. So my first thought is, well, why don't I substitute instead of AB equals BC, how about I substitute CE in? So I substitute that in there, and I know that CE equals BC. The reason? Well, I use the word substitute. It's the substitution property of equality. Now, that's all good and well, but I also know that now that CE equals BC, I can substitute that in there. And I get my fourth statement that DC equals BC. Once again, because of the substitution property of equality. Well, now I've got these things that say, hey, you know what? DC equals BC, which is really, really close to what I'm trying to prove, but it doesn't match exactly, and it should. So what we're going to do is go ahead and flip those around and say BC equals DC. And that, ladies and gentlemen, is the reflexive property of equality. And I know I'm done because step 4 says you're done when you have the proven statement. And look, that's what I'm trying to prove. So I know I'm done. 5 steps, couple substitutions, definition of midpoint, but we went ahead and proved that BC does in fact equal DC. All right, let's go ahead and look at the next one. So I'm going to give you about 45 seconds. Try and get this one written down. Now, as some of you are getting this written down, you've got about another 10 seconds or so. I want you thinking to yourself, what do I write down first? And then from there, how do I move from that? So, ladies and gentlemen, let's go ahead and take a look at this. given is that P is the midpoint of JK, and we're also given some information in that diagram. So look at my given information here. P is the midpoint of JK. That's right here. JP equals X. That's what this part of the picture is telling me. And PK equals 5X minus 8. That's what this part of the picture is telling me. So all three of those pieces are given information that we should write down first. What's my reason? Because they're given. Now, from there, guys, anytime you're given something that something's the midpoint of something else, your next step should probably be writing out that definition of midpoint. So if P is the midpoint in JK, then that means this length, JP, should be equal to that length, PK. My reason? Definition of midpoint. Okay. Realistically, if you're given midpoint, that's probably going to be one of our next steps. Now, from there, well, what do I know about JP? I know JP equals X. And what do I know about PK? Well, I know PK equals 5X minus 8. So using a little substitution, I can say that X, which I substituted in for JP, equals 5X minus 8, which I substituted in for PK. Reason why? Substitution property of equality. Now, from here, it looks like I just have an equation, kind of like we worked on yesterday. So my first step, my next statement is going to be negative 4X equals negative 8. What did I do? Well, I subtracted 5X on both sides, meaning my reason is going to be the subtraction property of equality. From there, my last statement is that X equals 2. What did I do there? Well, I went ahead and used the division property of equality. And I know I'm done because I've gotten from my givens all the way to what I'm trying to prove using reasons the whole way. So that is what that proof should end up looking like. Now, remember, as we go, if as a class we need it paused, pause the video. You can look over things, make sure you have stuff down. If it's just you and you don't want to raise your hand to ask to get the video paused, you can always go back and look at this on Schoology as well. So I'm going to give you about 45 seconds or so. Try and get this information written down. Our givens are that segment FG is congruent to segment HK. I also know that FG is equal to 4X minus 6 and HK is 22. And I'm trying to prove that X equals 7. So once again, as you're getting this written down, before we get started on it, as you're getting this written down, make sure you're thinking to yourself, start with my givens. Then go step by step. I've got to give reasons every time. I know I'm done when I get to X equals 7. All right, ladies and gentlemen, you should have it written down, hopefully. So from there, let's go ahead and look. My givens, well, we said segment FG is congruent to HK. I know FG is equal to 4X minus 6 because it's over here in the picture. And I know that HK is equal to 22 because, once again, it's over here in the picture. So my reason for saying all three of those things are true is that they were given to me. Now, from there, let's see. I really probably want to get FG and HK equal to each other. So how do I do that? How am I allowed to say that FG is equal to HK? Well, I knew they were congruent, and the definition of congruent segments says if they're congruent segments, then they're segments with the same length. So I can say FG equals HK. From there, I know FG is also 4X minus 6, so I could probably substitute that in. And I know HK is 22. I can substitute that in as well. So I have 4X minus 6 equals 22. Once again, anytime we're substituting in, it's the substitution property of equality. From there, we're just going to go ahead and solve through this equation using the difference property or the different properties of equality we know. So let's start by adding 6 to both sides, and we get 4X equals 28. That is because of the addition property of equality. From there, I need to get rid of that 4, which I'm going to divide on both sides, which gives me X equals 7. And because I divided on both sides, that is the division property of equality. And I know I'm done because I got to what I was trying to prove, X equals 7. Each step along the way, I had a reason for doing. A lot of them right now, because they're algebraic proofs, are because of those properties of equality. Definition of congruent segments and midpoint, also very helpful. All right, ladies and gentlemen, let's try the next one. So this one, the first thing I noticed with this one is there's no picture. So we're going to go ahead and draw ourselves a diagram and use it as we go. So I'm just going to read what's on here while you're writing it down. The given is that C is between A and B, and that the segment AC is congruent to CB. We are trying to prove that C is the midpoint of segment AB. Now, while you're writing this down, I want you to think about, how would I draw C is between AB? And how would I label on there that AC is congruent to CB? Guys, getting your diagram drawn is all part of doing these proofs and keeping everything organized. So give you about 10 more seconds, try and get this written down. All right, now, before we even start into our two-column proof there, I'm going to go ahead and draw a little bit of a picture here. So let's see, we've got this line segment, which I'm going to say is AB, and it says up there that C is in the middle. So there's C is between AB. Now, I also know that AC, this line segment, is congruent to CB, this line segment. So that's information that was just given to me I could draw a picture from. So let's start with our statements. Well, our first statement should be our given, that C is between A and B, and that AC is congruent to CB. The reason for that is our given. Once again, I'm going to keep pointing this out. Notice we had two different given pieces of information. Because they're happening at the same time, I can go ahead and write them both as statement number one. From there, ladies and gentlemen, what does AC being congruent to CB tell me? Well, it tells me that AC should be equal to CB because the definition of congruent segments. Okay, so because they are congruent, that also means they should have the same length. That's what the definition of congruent segments is telling me. Now, from there, if I know that AC is equal to CB, they have the same lengths, well, then I can claim that C is the midpoint of AB because that's the definition of midpoint. The definition of midpoint said that if a point splits it in half in two equal parts, which is what we did, then it's a midpoint. So I know I'm done because I proved that C is the midpoint of AB. Pretty quick little proof there, but we went ahead and proved that was true. All right. I believe there is one more. So this is our last one. When we're done with the video, so right now you should be writing down as I talk. You should be writing this stuff down. But remember, when we're done with the video, you should have picked up the practice sheet as class was starting, as you walked in the door. You need to be working on that practice sheet. Okay. The answer key will be on Schoology at some point today, and you can always check it then. The substitute also has an answer key, and so you can kind of help get that checked if you'd like. Now, while you're writing this down, I'm just going to read the information. So given, I know y is the midpoint of xz. I also know that segment xy is congruent to segment wy. I'm trying to prove that wy is congruent to yz. Now, just like that last one, we're going to want to go ahead and maybe draw ourselves a bit of a picture here, which we'll do in about, let's call it 12 seconds. All right, so let's start with our picture. Y is the midpoint of xz. So let's see, there's x, we'll call that z, and I know y is the midpoint. Now, what does that tell me? Well, it tells me that x, y, and yz should be the same lengths. So that might be a useful piece of information. And then it also says I have a wy here, so I'm just going to draw w up here and say I have this segment. Okay. Now, one thing I can do is I can go ahead and mark that this is congruent to this because that's one of the pieces of information I have. What I'm trying to prove is that WY is congruent to YZ. So let's start. First statement is that Y is the midpoint of XZ, which we should know because it's a given, and that XY, segment XY is congruent to segment WY. Both of those are because they're given to us. From there, ladies and gentlemen, Y is the midpoint of XZ. I told you a couple problems ago. If that's the case, then I should know that XY is equal to YZ. Why should I know they're equal? The definition of midpoint. Now, because those are equal, I can also say that XY is equal to WY. So this right here, I can say those are equal lengths because of the definition of congruent segments. So I can say, let's change to a different color here. We'll go purple. I can say these are the same length, definition of midpoint, and I can say that, we'll go green. I can say that these are the same length because of the definition of congruent segments. Okay. Let's see if I can erase those without erasing my picture. There we go. Now, from there, what else can I say? Well, if I know XY is equal to YZ, and I know XY is also equal to WY, then I know YZ and WY are equal. And you can either say that's through the substitution property of equality or the transitive property of equality. Either one of those things is perfectly fine. From there, I'm not trying to prove that they're equal. I'm trying to prove that they're congruent, which my next step says that they are congruent. How do I know? Well, if they have the same length, then that means the definition of congruent segment says they are congruent. So that would finish that proof. All right, ladies and gentlemen, that is it for me. You should have some time left in class to work on your practice. Once again, the substitute should have the answer key. The answer key will also be put online on Schoology. So that is it for me. I will see you guys in class tomorrow.